Hey folks, just a quick intro to our next unit on dynamics. Dynamics focuses on forces, and so it's going to focus on interactions between objects, and it's going to start to answer the questions about why things move the way they do and why things change their motion and how they do that. And so I'm going to introduce some new units and then talk about this idea of fundamental forces. So the two new quantities in physics for this unit are mass and force. Mass is something that you're familiar with from chemistry. It's describing the amount of matter in a substance. The abbreviation for mass is lowercase m. It is a scalar quantity, so only its magnitude is reported, and these numbers are anywhere from 0 to positive infinity. The units of mass for physics are kilograms. A force is any push or pull caused by any object or particle. And so there's lots of types of forces. Force is a vector quantity. So obviously, like if you need to pick something up, you need to exert a pull on it in the upward direction. Or if you're trying to get something away from you, you are pushing on it in a direction that is away from yourself. So magnitude and direction are both important. And then as far as the units go, this is the first unit of this course that we've seen that's named after someone, named after Isaac Newton. So the unit for force is called the Newton, abbreviated with a capital N. And the Newton is a derived unit, meaning it's just a shorthand for a set of units. And so the unit Newton, 1 Newton, is defined as a kilogram meter per second squared. So that's like kilograms times meters divided by seconds squared. And maybe you look at that and it doesn't make any sense, but maybe you're also looking at it and saying like, hey, I think I know what's going to happen later in this unit because of those units and how they're arranged. And so the whole unit is about forces and applying more or less Newton's second law to our understanding of forces and kinematics. The other part of this video is fundamental forces, and I just wanted to talk very briefly about the 4 fundamental forces, or is it 3, or is it 5? So these are called fundamental forces because they are things that scientists believe they have proven are due to specific particles in the universe. In other words, there are specific particles that like carry these forces, and they exist because of those particles. The forces that we talk about are mostly not fundamental forces. They are um, consequences of the electromagnetic force. And so we'll talk about that throughout the unit. But the 4 are listed here. They've gone through some name changes, and there might be 4 of them, or there might be 3 of them right now. I actually don't know. But we have the first one is the strong nuclear force, which is now just called the strong force. It is the force that holds the nucleus together. So it is the strongest force of them all, but it acts over such a small distance that we don't feel it. So forces have specific or general ideas of like a range of forces. So the strong force has the greatest magnitude in general, but it acts over the smallest range, the nucleus of an atom. So we don't really talk about that in this course. The electromagnetic force we talk about a lot, and you would, if you take physics again, you will talk about it a whole bunch. But this is a force that exists between charged particles that can be stationary or in motion relative to one another. This force has an infinite range, and it is relatively strong also. So these are kind of listed in order from strongest to weakest. So the forces of interacting charged particles are relatively really strong. But just not as strong as the strong. Next in the line is the weak force, which was called the weak nuclear force. This is the force that also happens inside a nucleus that determines a rate of nuclear decay for an isotope. So this is the like force that governs radioactivity. It also has a really short range. It doesn't hold the nucleus together. I'm not really clear on what it does specifically, but it exists pretty much only within the nucleus of an atom. Lately, I believe in physics, these two forces have been combined or unified into what is called the electroweak force. And so if you want to become a particle physicist, go learn about those things and then come back and tell me about them. The last force of all is the simplest, it's gravity. It is the weakest of all of the forces. It acts over an infinite range, so the entire universe, and it is a an attractive force that is due to mass. So the more mass something has, the greater its gravitational field is, and so the better able it is to pull things toward itself. So again, these are listed from strongest to weakest. It's just a matter of um, the size of the objects that are carrying these forces, where you would maybe think of gravity as a really strong force because of the size of the objects. We study the electromagnetic a little bit and gravity a lot, but that's just a tour of the fundamental forces in physics. In a future video, we'll talk about some specific forces that are, again, consequences of the electromagnetic force.